Now we'll take a look at simplifying expressions, rational expressions that involve multiplication and or division. So keep in mind that the same rules still apply. We need to find all the common factors in the numerator and denominator. Now, simply enough, you can do this in separate steps if you want. You could either first multiply the two numerators and the two denominators together, and then after multiplying the numerators and the denominators together, then factor out or cancel out the common parts. Or you could choose to actually do some of the canceling out first and then take the leftovers and multiply them together. The problem with this second method is you may end up having a second level of clearing out some of the multiplied parts together, but it's going to change or be different from problem to problem, so you'll have to use your experience with that. Now, some of these problems that we're dealing with now are similar to the exponent properties that we used back in previous units. So that you can see here in example number 2, we have multiple variables, and we're going to use our exponent properties to multiply them together. So you can see in the solution to example number 2, we elected to multiply the numerator and denominator first, and then apply the exponent properties through the division, thus leaving us with a simplified version. So this type of problem should look very familiar to you. Now, you have 3 examples to work: sample problem number 2, sample problem number 3, and sample problem number 4. So go ahead and work those 3 sample problems and then come back and take a look at the solutions. So if we look at this problem, what I went ahead and did was go ahead and multiply the numerators and the denominators together first. Then, if you remember, when we did exponent properties, we suggested that taking each of these parts, the numerical parts, the x values and the y values, and doing them separately may be the best way to go about doing this. And so that's what I went ahead and did. So we have 5/3, x to the third, y to the third. For sample problem 3, what I elected to do before multiplying everything together was to actually factor the 2 parts. And the reason I did that is because if I would have multiplied everything together initially, I would have gotten some very big, ugly polynomials that would have been really, really challenging to factor on the back end. Now, keep in mind that whenever you are multiplying, technically everything on the numerators together, everything in the denominators together, and so technically anything that's on top and bottom can be canceled out. So I can go ahead and start canceling out right off the bat here with 4x and 4x, and then I also have x plus 3 and x plus 3. Now I'll go ahead and stop right there and just rewrite what I have left over. Now I've gone ahead and rewritten the given material so that we can see what's left over here. Now we have this term 1 minus x, we have x minus 1 in the denominator, and they look like they have something in common, but they're not exactly the same term. So what you can do is you can see here that you could actually rewrite this first term in an order that looks familiar. And you can clearly see that the negative x plus 1 is not the same as x minus 1. However, you can actually factor out a common negative 1 from that first term. And so if we do that, what we end up getting is an x minus 1 left over. And so now we have a situation where we can cancel out the x minus 1s. Now I'm going to go ahead and choose to redistribute this negative 1 back over here to this x minus 2, so my final answer, simplified, is negative x plus 2. Alright, so let's take a look at the next sample problem. Now this one can be a little bit tricky if you're not paying attention, but keep in mind that this second term is really all over 1. Now, here's where you have to reach back a little bit to your polynomial functions. 4x squared plus 2x plus 1 actually cannot be factored, and so you have to be real careful about trying to factor that up front. But I'm going to go ahead and multiply together, or at least put together the numerator. Now, if we look at 8x to the third minus 1, that is a sum or difference of cubes in this case, And so we can't actually factor the difference of cubes. And so if you remember the SOAP acronym for same, opposite, always positive, that tells us what our signs are going to be in this factor. And if you notice here, we actually ended up having a quadratic that is the same, that can cancel out. And we get our simplified value.